Okay, hello class. This is our introductory class in terms of general physical science. I just want to welcome you. Thank you very much for joining this class. You will have a great time between the lecture and the labs. It's my earnest sincere that you would add value to the body of science and to the body of knowledge that all of us are experiencing in this dispensation of time. Technology is just coming out of everywhere, from finance and to engineering to textile to various industries. It's an exciting time, and I just wish you all the best. And my expectation that you guys will do well, not only in the class, but you'll do well in your careers. Um, so as we dive into our fundamental physical science class, we want to talk about measurements. It's a very important topic because without measurements, it's definitely hard to do anything um, quantitatively. Okay, um, we want to, as we move forward, we're going to be talking about units and what does it mean in terms of scientific notation. Okay, um, our senses typically um, have limitations. When we look at our smell, our taste, our touch, um, all these different senses, they have limitations to it, and sometimes they can kind of give us some kind of false information when it comes to trying to measure data or any kind of information that needs to be published. Okay, so in order to describe nature accurately, okay, or any kind of experiment accurately, we need to be able to take some experiments, right? And these experiments have to be expressed, right? They have to be expressed both in magnitude and in their units, which we'll get to as you go forward. Okay. Um, the fundamental quantities, right, are typically just describing an object. Quantities typically they describe an object, and what do we mean by that is if I tell you uh, 10, you ask me 10 what? Is it 10 meters? Is it 10 mangoes? Is it 10 feet? Is it 10 feet squared? You're going to ask me 10 what? So this is what we mean by we can be able to describe an object, typically by quantifying it. Okay, so fundamental quantities are commonly referred to as dimensions, as I said before, meters, feet squared. Okay, um, a standard unit typically is fixed and it's reproducible value, right? For the purpose of taking accurate measurements. So this is something that has been a standard unit, something that has been tested from time to time, and it's proven to be true. It's proven to have accurate measuracy. And what we mean by that is we know that 12 inches equals 1 foot. I mean that has been tested over and over and over again. Okay, so a group of standard units, right? And their combinations are typically known as a system of units. Okay. And now, when we say system of units, we have primarily two. We have what you know as SI units, right? Which typically uses kilometers, meters, grams, etc. And we also have what you know as a British or English system, or some people call it imperial system. You hear people say that, and that's in miles, inches, pounds, seconds. And like seconds, really, in the imperial or the British system, is the same thing as seconds in the metric system. Okay. Now, when we look at a unit of length, right, all we're doing is we're just measuring a space in any direction. And what we mean by any direction, it could be the z direction, the x direction, it could be the y direction. But what one needs to keep in mind is there's always going to be some form of origin. So, man, when you go to your x or y or z directions, you started from somewhere. Okay? And in the metric system, we can classify a unit of length as a meter. In the British system, that would be a foot. Okay? So here's how a unit of length can be quantified as an application. Is if you're pouring water into some defined space, you have the height, which is a unit of length. You have the length, which is also a unit of length. And what I mean by unit of length typically means that it's primarily just a length, which can be measured in meters or in feet. Okay, and you have the width, which is also a unit of length. Okay. Now, as a meter is typically being defined, a meter is typically defined by the distance of light that travels in a vacuum, right, and a small fraction of a second. So this is how the evolution of how a meter came into being, by them measuring typically as distance as light travels in a vacuum. All right. Um, so you have this typically also from the equator point of view as well as from the light point of view. So this is how a meter typically was being quantified. Okay. Now mass, if we were to define mass, is nothing more than the how much an object contains. Okay. Um, Again, mass is matter that contains objects. Okay, so keep that in mind. And mass should not be confused with weight. Okay, those are two different realms, um, and they should not be confused. When you're talking about weight, you're talking about some association to acceleration due to gravity. Okay, but this is not the case. Okay, so mass is nothing more than the amount of matter that an object contains. Okay, and it could be measured in kilograms as far as the metric unit is concerned, and in terms of the British unit, slugs, which is rarely used, but that's the how it's being coined or how it's being termed under the British units. So a kilogram, which typically measures mass, right? Is seen here where we have the mass of a cube of water, right? So again, this mass, in conjunction with the unit of length of how this particular water is being contained, is identified here. Okay, and all this will make sense as you go further in the lecture. Okay, time, which is another fundamental quantity, is the speed of the continuous forward flow of events. Okay, so it's interesting to know um, how time evolved, what we know time to be. But the National Institute of Standard Technology, they typically they set, or their cornerstone institution, they kind of set um, how time should be interpreted. Okay, and time typically is measured in seconds, or it can be in minutes, or in hours, or in days, or in years, etc. Okay. Again, the second is defined in terms of the frequency of radiation emitted from the cesium atom. So cesium, it's an element on the periodic table, and according to the the National Institute of Standards and Technology, NIST, there's an association between the atom and how it oscillates in regards to time. So when we look at our metric system, we notice that our length can be measured in meters, our mass can be measured in kilograms, the time can be measured in seconds, and these are the abbreviations of those typical units. Okay, ampere is electrical current, capital A. Your temperature is in Kelvin, and the amount of a substance can be measured in as a mole. Okay. So we have non-standard metric units. Here we're just typically dealing with a liter. Okay. Now we are moving into more of a liquid type of structure. Here, the mass of a cube of water, 10 meters on all sides, typically has a mass of 1 kilogram. Okay, so you can make the relationship saying that 1 kilogram equals 10 cubed centimeter cubed. Right, so that's 1 kilogram equals 1,000 centimeter cubed. Okay. Now, kind of want to keep these relationships in mind. 1 centimeter cubed equals 1 milliliter. Likewise, 1 milliliter of water has a mass of 1 gram. Now, once we've established our units, we can derive other units. For instance, unit of length. If I multiply two lengths together, that will give me m squared, or centimeter squared. If I'm in the imperial system, it would be feet squared. Okay, or it could be inch squared. Okay. Volume tells me that if I multiply 3 units of length, I will get a volume, and the unit to display that will be m cubed, or centimeter cubed, or feet cubed, or inch cubed. Okay. Inch cubed. Okay. Okay, I'm going to stop this video here, and I'm going to try to fix this problem that I'm encountering right here. Okay, thank you very much. I'm going to continue on derived units, density. Thank you very much.